Hey everybody, like I told you earlier in the week, I am going to be gone today. I'm also going to be gone tomorrow as well as Monday and Tuesday of next week. So unfortunately, this is kind of going to be how we need to run the classes here. I'll be up here doing a video with you and all the homework will already be built. So the course is not going to be changing that much. It just means that you have to watch digital me instead of actual me. But we are going to be going through a lot of stuff. We're not pausing while I'm gone, which means the test is going to come up pretty quickly after I get back. So it's really important that you still stay in your seats, get your work done, pay attention, fill out the notes, and do all of those things. Because as soon as I get back, we're going to be taking a test pretty quickly. So you still need to master everything and be ready to go here. Fortunately, you have an excellent sub that knows her stuff and can help you with everything that we're doing today, tomorrow, Monday, Tuesday, all of those days. So please use that resource and please ask her if you have any questions. The goal today is to talk about isosceles and equilateral triangles and a lot of their properties. If you recall from Monday, an isosceles triangle is a triangle that has two sides that are congruent to each other, and an equilateral triangle is a triangle that has all three sides congruent to each other. So we're going to begin with just the isosceles triangle. And we know already that this is definitely an isosceles triangle because we have one leg that's congruent and another leg that's congruent and a third that is not. So the legs of an isosceles triangle, if you recall when we were talking about isosceles trapezoids, the legs were the two sides that were congruent to each other. We had the two sides that were parallel and then the two sides that were congruent to each other, meaning they had the same length, and those were going to be our legs. And the other two sides, the parallel sides, the non-congruent sides, those were our bases. And just like those were our bases for an isosceles trapezoid, you can see here the base is also our non-congruent side for our isosceles triangle. So a lot of the terminology that we used with isosceles trapezoids is still true here in isosceles triangles, including the bases. The two angles at the base are an isosceles triangle. Now, if you recall again to isosceles trapezoids, we had two different pairs. Each base had its own pair of two angles. But here in an isosceles triangle, our first base and our second base, whoops, double click there, sorry. We've only got the one pair here. Notice that when we talked about opposite, they are the two angles opposite by two congruent sides, or they're the two angles that are connected to the base of the isosceles triangle. All right, the base angles theorem. The base angle theorem states that if AB of a triangle and AC of a triangle are congruent, then angle C will be congruent to angle B, and that those two are going to be congruent. Basically, if you have an isosceles triangle, the base angles are going to be congruent. So we have two congruent sides and we have two congruent angles. So trying to find the measure of angle L here. If angle L is a base of an isosceles triangle, then from the base angles theorem, we know, and we also know that this is an isosceles triangle, that angle N and angle L are going to be congruent to each other. If angle N is 52 degrees, then angle L must also be 52 degrees. Notice again that this angle is opposite this side, and this angle is opposite this side. So that's how I know that these are my two congruent angles. They're also the two angles that are on the base. The converse. If you remember earlier in the year when we were talking about converses a lot, because this has a lot to do with a lot of the proofs that we're doing, the converse just means we're going the other way. So with the previous triangle example and with theorem 4.3, that stated if I've got two congruent sides, then I also have two congruent angles. The converse of the base angles theorem states that if I have two congruent angles, then I've got two congruent sides. So if B and C are congruent, and we can see they are because they're marked as congruent, then AC will be congruent to AB. So we're going to use the converse of the base angles theorem to find the value of x here. And I know because this is an isosceles triangle and I've got two angles that are congruent to each other, that x plus 3 is going to be equal to 12. So I'm going to bring this out here. I prefer to do my math on my own. If it lets me here. So I can then, because the measurements are equal, just set those two measurements equal to each other. Whoops, give me the pen. X plus 3 equals 12. And then to get x by itself, we need to drop this down, subtract 3 from both sides, and x will equal 9. Remember, we've talked about this a lot in this class, that if you have two measurements that are congruent to each other, two measurements that are equal to each other, the way you're going to be solving for missing variables is to take those two measurements and just set them equal to each other, and then solve and do the algebra. So we're going to go ahead and go back there. I'll click onto my mouse, and if you want to, and it's a good idea, fill in, this is the same stuff, it's just a little more proofy is the word that I'm going to use for it, but this is the way that they have everything structured in your notes. Again, same thing, they just don't show you all of the algebra. But they do describe it, as I state. All right, so we're going to take a second here, and we have 3 example problems, 3 checkpoints. So I'm going to ask the sub to pause the video here and then hit play again when all of you are done with these problems. So take a minute and get to work on those 3. All right, welcome back. So staring at these problems. Problem number 1, we see that we have an isosceles triangle. We know it because we have 2 congruent sides, which means our opposite angles have to be congruent. So y and 50 have to be the same. So the answer to that first one will be 50. And just like earlier, we've got 2 congruent angles. And if we have 2 congruent angles, we also have 2 congruent sides. So if the one side is 9, the other one must also be 9. And then for, not sure what that is, number 3 here, we know that 16, the side with 16 is going to be congruent to the side with y plus 4. So we'll set those two equal to each other, subtract 4 from both sides, and get 12. All right. The equilateral theorem. If a triangle is equilateral, then it's equiangular. I believe I've mentioned this already in a couple of the classes, but if all 3 sides are the same, then all 3 angles are the same. And 4.6, if all 3 angles are the same, then all 3 sides are the same. So equilateral and equiangular are different ways of describing the same triangle. Equilateral is mentioning that all the sides are the same, and equiangular, all the angles are the same. But the truth is, they're actually the same. That if you have one property, you have both. So looking for the side length of each side of the equiangular triangle, hide that a little bit. Still not sure if you can see that or not. We know that because this is equiangular, that it's also equilateral. All my angles are the same, so then all my sides have to be the same. So I have one side that is 3x and another side that is 2x plus 10. We talked about this earlier. If you have measurements that are the same, 2 sides that are congruent, take the measurements, set them equal to each other. So 3x equals 2x plus 10. We're going to subtract 10 from both, we're going to subtract 2x from both sides is what we're going to do, because that would be smarter. The 3x minus 2x will give us x. We've got just a 10 left over on the other side, so x equals 10, which means, because we're looking for the side length, once we know what x is, we need to take x and plug that back into either of our equations. The textbook shows to do 3 times 10, which is probably the easier equation, which is 30. So the side length of RQ, or any of the sides, is 30. So a couple follow-up questions here. Example 2 and example 3, how are they similar? They're both using congruent angles to find congruent sides and then solve for x. However, example 2 has an isosceles triangle, and example 3 is equilateral, but they do have some very similar properties. As you get more things in common, you get more angles in common. That's a terrible sentence. That's probably going to be useless to you. Sorry. That's not your assignment. Your assignments are already posted into Schoology. All of the homework is there. So as soon as this video stops, go ahead, jump into your homework. Make sure that you complete that to the point where you understand everything that's going on. Remember, comprehension is the goal. So make sure that you are doing the assignment, reviewing your incorrect answers, and I'll see you in a few days.